What's up? Welcome back to my tutorial channel. Daniel's here and today I'm gonna finish topic 8 hypothesis testing. And up to now we have learned three tests, z-test, t-test, and one proportion z-test. So the purpose of the lesson today is to determine what test to use. So here's a map. When we work with one random symbol, and we want to test a claim about a parameter, we need to ask ourselves which parameter that we are interested in. So in this chapter, in this topic, we have learned two parameters, mu and p. Mu is the population mean and p is the population proportion. So if you are testing a claim about the population mean mu, the next question is whether the population's innervation is known or unknown. If the population's innervation is known, the next question is the sample size whether it is at least 30. So if the sample size is at least 30, the central limit theorem is applicable, so we can use z-test. If the sample size is less than 30, we need to check whether the original population is normal. If the original population is approximately normal, whether the sample size is at least 30 or not at least 30, z-test would work as well. If the sample size is less than 30 and the original population is not normal, then we need to use different method. And bootstrap is one recommendation. If for population mean mu, sigma is unknown, we need to check whether the sample size is at least 30. If the sample size is at least 30, the central limit theorem is applicable and we can use t-test. And remember, when sample size is large, the student t-distribution will be approaching the standard normal distribution, so z-test is applicable as well, and we can use S as a substitution for sigma. If the sample size is less than 30 and the population is approximately normal, we use t-test. If the sample size is less than 30 and the population is not normal, is not approximately normal, then we need to use a different methods, and bootstrap is one of the methods that I think would work fine for this situation. If we are dealing with a claim about population proportion, we also need to check whether the central limit theorem is applicable. So if NP and N times 1 minus P is at least 10, we use one proportion z-test. Otherwise, we might think about some other statistical methods, and bootstrap is one example. So that's how we determine the test to use. Now let's go over some example. Example 1, starting salaries for a simple random sample of 51 physicians had a mean of 103,000. Assume that the population's innervation is 10,500. Can you conclude that the mean starting salary for physicians is greater than 100,000? Determine the type of parameter that is to be tested and perform the hypothesis test. So here our first question is what parameter that we are interested in. To determine which parameter, we read the claim. Can you conclude that the mean starting salary for a physician is greater than 100,000? The mean starting salary, this is a keyword. So we are working with the population mean. So the parameter here is mu. The next question is whether the innervation of the population is known. And here we have assumed that the population's innervation is 10,500. That means sigma is known. So we think about z-test. So let's check assumption to see whether the central limit theorem is applicable. And we see that the sample size here is 51, which is greater than 30. So the central limit theorem is applicable. And sigma is known. And we work with mu. So the test we would like to use is z-test. And in this lecture, I don't show you how to run a z-test again because I have one video that show you how to run a z-test. So basically for this video, I just want you to determine what test to use. So for this problem, the test to use is z-test. Next, example 2, saving for college. In a survey of 909 US adults with children conducted by the Financial Industry Regulatory Authority, 309 said that they had saved money for their children's college education. Can you conclude that more than 30% of US adults with children have saved money for college? So the first question is which parameter that we are working with, and we read the claim. Can you conclude that more than 30% of US adults with children have saved money for college? 30% is a percentage, so we are working with proportion. So the parameter that we are interested in is population proportion, P. So we think about one proportion z-test. But to see whether one proportion z-test is applicable, we need to see whether the central limit theorem for proportion is applicable. So we see here NP is 309 and n times 1 minus p, which is 600. So both NP and n1 minus p is at least 10. So the central limit theorem is applicable. That means we can use one proportion z-test. Next, example 3, big houses. The U.S. Census Bureau reported that the mean area of U.S. homes built in 2012 was 2,505 square feet. Assume that a simple random sample of 20 homes built in this year had a mean area of 2,581 square feet with a standard deviation of 225 square feet. Can you conclude that the mean area of homes built in this year is greater than that of homes built in 2012? Use interval level of significance. So here we, the parameter that we are interested in is the mean area of homes built. That is the population mean. So we work with mu. The next question is whether the standard deviation is known or unknown. And we see here we have we don't have any information about population standard deviation, which have the standard deviation of the sample, which is 225. So the population standard deviation in this situation is unknown. So we think about t-test, but to see whether t-test is applicable, let's check the sample size. So the sample size here is 20, which is less than 30. So central limit theorem is not applicable. So the next thing we need to check is whether the original population is normal. And there's no information that the original population is normal. So that means t-test doesn't work in this case. And z-test doesn't work either, of course. And this test is not for proportion. For one proportion, z-test is not applicable as well. So none of the three tests is applicable. And we think about bootstrap. Bootstrap is not covered in elementary statistics because it's an advanced level statistics. Next, example 4, mercury pollution. Mercury is a toxic metal that is used in many industrial applications. 7 measurements in milligrams per cubic meter were taken of the mercury concentration in a lake, with the following result. Assume that the population of measurement is approximately normal distributed. Can you conclude that the mean concentration is greater than 1 milligram per cubic meter? Use alpha level 0.05. So here we have, we need to determine which parameter that we are interested in. So let's read the claim. Can you conclude that the mean concentration is greater than 1 milligram? So the mean concentration, that means the population mean. So the parameter is mu. The next question is whether the population's innervation is known. And we are given a symbol and there's no information about the population innervation. So sigma is unknown. And when we look at the symbol, we see the symbol size 7, which is less than 30. So the central limit theorem is not applicable and t-test is not applicable. However, if we read carefully, we see assume that the population of measurements is approximately normal distributed. So the original population is approximately normal. Therefore, we can use t-test. I repeat, even though the sample size is less than 30, but because the original population is approximately normal, so the symbol, this symbol is approximately normal. That's why we can use t-test. So I've been talking about bootstrap. So what is bootstrap? In this lesson, I'm not gonna give you a deep learning about bootstrap because bootstrap is kind of an advanced statistical method. However, I'm gonna try to give you a general picture of bootstrap. So bootstrap is basically a method that is used to deal with small samples. The idea is to replicate a sampling procedure a very large number of times, say 5,000, 10,000, or even more. In its replication, we withdraw a simple random sample from the original small sample with replacement. Then for each sample obtained, we process the hypothesis testing. Finally, we count the number of times that the null hypothesis is rejected and divided by the total number of replication. So let's say, suppose out of 10,000 times, we reject the null hypothesis, let's say like 95%, which is around 9,500 times, then we reject the null hypothesis. So let's say the original sample is 5, 6, 4, 8, and 7, which is a very small sample with sample size only 5. And we want to test to see whether the population mean is greater than 5. So we use, let's say we use like 5,000 or 10,000 replication. In the first replication, we withdraw a symbol of size 5 from this original symbol with replacement. That means we withdraw the first number randomly and put it back and withdraw the second number until we have 5 numbers. So we got the first symbol and then we proceed t-test using symbol 1. And we see for this symbol we reject the null hypothesis. Then we withdraw another symbol with the same procedure with replacement. And then we use the second symbol, we see that we do not reject H0 and continue so on until the symbol 5,000. We reject H0, for example, H0. So here we take the number of times that we reject the null hypothesis divided by the number of replication. And then if it's greater than 95%, we can reject the null hypothesis. So that's a general idea of bootstrap. Of course, we have many different bootstrap. We might have non-parametric bootstrap or parametric bootstrap. So in this lesson, I just want to introduce the method. But of course, for elementary statistics, you don't have to deal with bootstrap. You just have to determine whether z-test, t-test, and one proportion z-test is applicable. So that's all for today. Thank you so much for watching my video. I hope you guys find my video helpful, and see you next time. Bye.